In this video, we're going to look at finding inverses ourselves. So in the previous videos and learning objectives, we looked at tables and graphs and kind of having individual points and finding the inverse, but now we're going to do it for an entire expression. All right, so we've had this thing before, function notation, f of x equals 3x plus 2. So for any x value I plug in, I'm going to get out 3 times that number plus 2. And how are we going to find the inverse of this function? Well, the first thing is having the function notation in this example is actually going to make it more complicated. So what does function notation represent? It represents the y value I'm getting out. All right, so that's the first thing I'm going to do. All right, so y equals 3x plus 2. I didn't really change anything, just remembering that function notation just represents what your y values are. And then what's the big thing we know about inverses? Inverses do the opposite of the original. All right, so inverses switch the x and y. So that's exactly what I'm going to do in this example. I'm going to switch the x and y. So this y is going to become an x, and this x is going to become a y. All right, because that's what inverses do. They flip x's and y's. So now we've kind of switched to the inverse function. And then now we don't normally like having our functions written as x equals. We like having them as y equals because x is our independent variable. So now we're just going to solve this for y. So the first thing I'm going to do is subtract 2 on both sides. I'm going to get x minus 2 equals 3y. I'm going to get y all by itself, so now I'm going to divide by 3. Right, and I'm just going to write the y on the left because that's normally how we see it. All right, but now the 3's cancel, we get y by itself. We get x minus 2 over 3. All right, so that is the inverse of the original function that I started with. All right, so this is the general process for finding an inverse, and here it is in words. So the first step we did, right, if there's function notation, if there's that f of x, I replace the f of x with just a y. All right, it's a lot easier to deal with just the y value, all right, rather than that function notation. And then what do inverses do? All right, we're going to change all the x's to y's and all the y's to x's. We're just flipping x and y because that's exactly what an inverse does. It changes those two things. And then the last step, which is the kind of actually hardest one, the first two are just single steps, all right, but solving the equation for y. So that's where all the major work going to be, is solving that equation for y. All right, so here's one for you to try on, very similar to the first example we did. All right, find the inverse of this function. All right, you should get something that looks like this. All right, so we go through again. First step, replace the f of x with the y, switch the x's and y's, and then solve for y. So add 2 to both sides, divide both sides by 5, and we get the y all by itself. So that is the inverse of the original function we started with. And as we make more complicated functions, the process is still the same. The only thing that's going to change is these kind of steps here where you're solving for y. It might be more complicated or slightly different. All right, so here's kind of the same problem, all right, but we're just a slightly more complicated expression. Now we're dealing with this rational function, this fraction. All right, but the first steps are still going to be the same. All right, we're going to replace the f of x with a y. Then we're going to change all the x's and y's, so now it's going to be an x here, 3y plus 2 over 4y minus 1. All right, so those steps have not changed at all. All right, replace the f of x with a y, switch the x's and y's. And now our next big goal is to solve for y. So we somehow want to get our y completely by itself. All right, here we have a fraction. All right, so whenever we're dealing with fractions, normally our first step is to get rid of the fraction. We do that by multiplying both sides by the bottom of that fraction. On the right hand side, the 4y minus 1s are going to cancel. We get 3y plus 2. On the left hand side, I have to distribute this x into both of those pieces. So I'm going to get 4y times x is 4xy. Minus 1 times x is minus x. All right, so that step's nothing really new. All right, when we try to get rid of a fraction, we multiply by the denominator. And now the next step's not necessarily new, but maybe it looks a little weird. All right, we're trying to solve for y. So normally when we're trying to solve for something and there's no exponents, all right, as soon as we put like an x squared here, everything changes. But we don't have an x squared here, so the problem's a little bit easier. Whenever we have just a problem like this, it's a linear equation. We want to get all the things we're trying to solve for on one side together. So we're trying to solve for y. So we want to get these two terms together on one side. The terms that don't have a y in it, we want to get together on the other side. All right, so I want to get the blue terms together. I'm going to subtract 3y from both sides. And I want to move the red terms to the right, so I'm going to add x to both sides. All right, so I'm just going to do these two steps at the same time. So these are going to cancel, those are going to cancel. On the right-hand side, that's the slightly easier one. We just have 2 plus x is 2 plus x. The left-hand side, you might be tempted to combine these two things, but they're not like terms. All right, like terms mean they have the exact same variable part. This has an x and a y. This just has a y. So for right now, I have to leave these two things separate. And here, when we're just dealing with one variable with just like an x, all right, our next step is pretty much divide and you're done. But here we have two variables in our equation and we're trying to solve for y. So our next step is we want this y by itself. Right now the y is in both of our terms because we got all the y's together. So what we're going to do is take this y and factor it out. All right, we worked on factoring before in a previous unit, but what we're going to do is pull the y to the front and see what's left behind. Well, if we're getting rid of the y from the first term, what's left behind is the 4x. If we get rid of the y from the second term, what's left behind is that minus 3. All right, so we just took this common y, both these things, and pulled it out to the front there. And now we want to get this y by itself. So what do? If we want the y by itself, we get rid of the thing it's being multiplied by. I'm going to divide both sides by 4x minus 3. Because that cancels out, and I get the y finally all by itself. On the right, I just get this kind of complicated looking fraction, 2 plus x over 4x minus 3. All right, and that is our answer for our inverse. All right, the good thing with these problems is they'll always be the same similar steps. All right, so if you take notes, all right, we're going to do another example. You'll see that follows the exact same pattern. All right, so here's another example. Same thing, just different numbers. All right, so first step, place f of x with y. Just to make the notation easier. Second step, switch the x and y because now we're switching to the inverse function. And now the big step is solving for y, but in solving for y, there's a bunch of little steps. All right, so it's going to be the exact same as the last example. First step, multiply both sides by the denominator. On the right-hand side, you do that because it cancels, and I just get the top of that fraction. On the left-hand side, I distribute. So I'm going to get 7y times x is 7xy. 4 times x is 4x. All right, next step after this, I have this kind of single line without fractions, no exponents. So that means I want to get all the things together that I want to solve for. I want to solve for y, so I want this and this together. Right, these terms do not have a y, so I want those on the other side of the equal sign. So I'm going to do is subtract 2y from both sides and subtract 4x from both sides. That'll get the red terms together on the right and the blue terms together on the left. All right, so now we're going to have 7xy minus 2y. Again, remember, you can't combine those because the variable parts are different. One has an x and a y, the other just has a y, so I have to leave these things separate. On the right, I get minus 3 minus 4x. All right, again, I can't combine those ones either because the 3 does not have an x. And now I got these y's together on this side, so now I factor it out. I'm going to pull it to the front. And what's left behind in parentheses is the 7x from the first term and the minus 2 from the second term. And my very last step, the whole time I've been trying to get y all by itself. So I'm going to divide both sides by that stuff in parentheses, because that's going to cancel out. Y equals negative 3 minus 4x over 7x minus 2. And that is our final answer. We finally got y by itself, and now we found the inverse of that original function. All right, so you can see an individual step might be a little confusing, but it's the same steps we're going to do every time when we start off with a fraction as our original function. All right, so here's one for you to try on your own. Again, you're almost just copying the same thing I just did, but with different numbers. All right, but make sure you're kind of understanding each step as you go. And here's all the work for what you should have gotten. All right, so replace the function notation, switch the x's and y's, multiply by the denominator. Remember to distribute on the left. Right, move the y's together and the other stuff together. All right, notice you have a common y, so you factor it out to the front, and then divide by whatever that term is to get your y all by itself. All right, so here's our final answer for the inverse of that function. All right, so for this learning objective, you're going to have to do a skill check. The skill check is going to do one linear expression like the very first example we did. All right, so it's just like y equals 5x minus 2 or something. All right, that's one example, and then one rational expression, just like the last 3 examples we did. All right, so one of each. All right, the practice problems are there for you to practice, but you know exactly what's going to be on the skill check.